बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज का जो हमारा टॉपिक है दैट इज अबाउट अनदर टाइप ऑफ क्रोमेटोग्राफी, वेरी इंपॉर्टेंट वन, दैट इज द गैस क्रोमेटोग्राफी। अभी तक हमने जो है मेनली वी हैव एक्चुअली फिनिश्ड द लिक्विड क्रोमेटोग्राफी एंड बेसिक्स ऑफ द क्रोमेटोग्राफी। तो गैस क्रोमेटोग्राफी एक इंपॉर्टेंट टेक्निक है एंड इट विल टेक लॉट ऑफ लेक्चर्स टू फिनिश। लेकिन जैसे आप जानते हैं ना, विल ट्राई टू मेक इट मोर कंसाइज, और हमारा एग्जाम ऑब्जेक्टिव टाइप है, सो विल ट्राई टू मेक इट लिमिटेड within the domain. Okay, the gas chromatography. Chromatography means it's an analytical technique that is used for separation of the components, molecules from a mixture. अब gas यहाँ word आ रहा है, तो एक important चीज यहाँ पे याद रखें कि ये जो chromatography है, gas chromatography, it's used for let us say we have a mixture which has to be separated. Fine. So let us say we have two components or three components. That means we have three molecules. This is our sample, the liquid sample. It's used this chromatograph technique for separating those molecules which are low boiling. They have low boiling point, very important. Low boiling liquids, or low boiling point molecules. जिनको easily हम वेपर स्टेट में कन्वर्ट कर सकते हैं, उसके लिए हम यूज करते हैं गैस क्रोमेटोग्राफी। फाइन। सेकेंड, इस केस में हमारा जो, जैसे मैंने कहा कि whenever there is a concept of chromatography, just straightforward, just keep in mind we have a column. ये बहुत ही important है, particularly when you are dealing with the objective type exams. So we have a column here. So इस केस में जो and then in you have the mobile phase that's actually flows through the column. This case में जो mobile phase है, that is a gas. This is very important. So gas acts as a mobile phase in the gas chromatography. And इस case में जो gas है, that is the which is unreactive. वो gas की reactivity which is not reactive, or this is almost जिसकी reactivity बहुत कम है, unreactive, or we can say they are noble, are inert gases. So for example, we have hydrogen, helium, nitrogen and so on. Most commonly hydrogen, helium use करते हैं, we can use nitrogen also. They should not react with our liquid, these compounds, which has to be separated. So this is the mobile phase. A stationary phase inside the column. ये stationary phase usually हम इसमें use करते हैं two type का. So if we compare the stationary phase, that can either be a solid or that is a liquid. और liquid का जब बात होगा, that should be a high boiling liquid. ये बहुत important है, high boiling liquid. ठीक, high boiling liquid. So if you use solid, it is called as gas solid chromatography. Gas solid chromatography. If our stationary phase liquid, it's called gas liquid chromatography. Or most commonly जो हम use करते हैं, that is this gas liquid chromatography. So in our lecture, in this lecture, I will go straight forward with the gas liquid chromatography. Fine. Now, so this is the basics about the stationary and mobile phase, and is valid for the compounds, for those separations where the components have low boiling and they can be easily vaporized. Now, इसमें और एक पॉइंट ये है, जितनी भी क्रोमेटोग्राफी हमने पढ़ी अभी तक, हमने कहा था कि उसमें जो मोबाइल फेज that actually passes to the column which is packed with some stationary phase, whether it is liquid or solid, हमने कहा जो एनालाइट इसमें होते हैं, पास करते हैं इसमें, एनालाइट इन द सेंस जो सैंपल हम इसमें छोड़ देते हैं, जिसको हमने सेपरेट करना है, दैट बेसिकली ड्यूरिंग द कोर्स ऑफ दिस सेपरेशन इट पार्शन्स इटसेल्फ बिटवीन द मोबाइल फेज एंड स्टेशनरी फेज. यानी यहाँ तो पार्शियल मैकेनिज्म था, एब्जॉर्प्शन, बट यहाँ ऐसा केस नहीं. यहाँ जो मोबाइल फेज है, इट डजंट हैज दैट उस तरह की वर्क यहाँ पे मोबाइल फेज की नहीं है. तो मोबाइल फेज बेसिकली व्हाट इट डज, इट एक्ट्स एज अ कैरियर, वेरी इंपॉर्टेंट. सो मोबाइल फेज एक्ट्स एज अ कैरियर हियर. That's why it's also called as a carrier gas. So mobile phase, which is the inert gas and unreactive gases like these, so they act as a carrier, or they basically act as a carrier gas Carrier means they carry something from one point to another. In this case, they carry the sample, these molecules, in the form of vapor state from into the column, and then they help them to go out of the column, to get eluted out of the column, and finally detected by the detector. So now we'll start about the basic mechanism. So these are the basics. Now, so पहले कि we'll start the basics now. So now this is our column. अब यहाँ point number 1 होता है कि जो है stationary phase. तो stationary phase हमारे पास होता है जिसमें लिखा है carrier gas. और carrier gas it's like hydrogen, helium, nitrogen. Usually oxygen concentration बहुत कम होनी चाहिए. Almost it should be out of the oxygen should not be there. तो हमारे पास जो सिलेंडर्स अवेलेबल होते हैं यूजुअली यू कैन सी इन द मेडिकल हॉस्पिटल्स दोस लॉन्ग सिलेंडर्स. तो लेट अस से इट इज आवर हाइड्रोजन और हीलियम इज द कैरियर गैस. तो दे आर द लॉन्ग सिलेंडर हियर. लॉन्ग सिलेंडर होता है यहाँ पे. सो दिस इज बॉटम ऑफ द सिलेंडर. तो यहाँ से इट्स फिल्ड विद द कैरियर गैस. दिस इज आवर मोबाइल फेज. नाउ दिस समथिंग इंटरेस्टिंग. ठीक, जैसे मैंने कहा the most commonly used is helium or sometimes nitrogen. Let us say it is helium in the vapor state. So carrier gas will move from here. ठीक, so your carrier gas is moving from here since it's volatile. ठीक, then we have a chamber here, छोटा सा chamber. इस chamber में here the sample is injected into this chamber. So we have a sample injection point here. Sample injection point. The sample injection is वहाँ पे basically it's like a syringe type system that injects the sample here. It's syringe type. Fine. और यहाँ पे इसमें so sample we have here it's in the form of liquid. So syringe we take with the help of a syringe. We take the sample with the help of a syringe here. With the help of syringe we suck the sample here, and then we're actually inserting here. This chamber the temperature is very very high. It's high temperature sample. So as the carrier gas goes inside, the sample now is getting volatilized. ठीक? So now we have the sample in the form of vapor state here. Sample in the vapor phase. Carrier gas gets mixed up. So now carrier gas then it from here यहाँ से actually is inserted into the column then. So basically with the help of tubing this carrier gas is inserted. Now carrier gas it carries with it the vapors. It's got mixed here and now it's going into the column. Fine. Now जैसे ही column में पहुंच जाते हैं, column is packed with जो मैंने कहा the most common column, that is it's packed with a liquid. ठीक? So a liquid should be a high boiling liquid like we have the silicon based liquid. So it is here packed in the column. और column यहाँ very important है. ये जो है it should be a it's यहाँ पे high temperature is here the case in the columns. So the column should be very very stronger. And its walls are very very strong. So it's usually made of stainless steel. तो ये stainless steel का होता है या it can be हम जो है glass column भी use करते हैं sometimes. Glass column. It's packed with the material. It can be silica usually. Silica. उसके अलावा यहाँ पे और एक सिलिका जो कॉलम में पैक्ड होता है उसमें और एक लिक्विड होता है एब्जॉर्ब्ड और पार्टिशन दैट इज एक लिक्विड होता है उसमें. That's why it's a liquid column. So मैंने कहा that's why it's a gas liquid chromatography. तो इसमें वो पोलर लिक्विड होता है यूजुअली. तो वो जो मटेरियल सिलिका होता है उसी पे वो एब्जॉर्ब्ड होता है. ठीक. नाउ एज द और उसके बाद ये इंपॉर्टेंट जिसमें कॉलम तो मैंने ऐसे दिखाया तो बेसिकली ये कॉलम होता है इट्स लाइक अ ट्यूब टाइप कॉलम. ट्यूब टाइप कॉलम मैंने एक इसका एक टुकड़ा यहाँ पे आपको लोगों को दिखाया. इट्स अ ट्यूब टाइप कॉलम. So you can make this tube here, it's a coil tube. It's a tube type column. Now from this tube, I'm actually trying to show it here for our simplification, a fragment of that. So it's basically ये जो it passes through tube type column और इस column के आसपास temperature बहुत high होता है. So it's basically inside some oven type of structure, fine. So इसका temperature हम control कर सकते हैं इसका temperature या तो हम static रख लेते हैं throughout the separation process, या we can actually vary the temperatures, ठीक? So it can be programmed. तो इसका एक fragment इसी column में जो है ये material is packed, and usually that our phase is basically the liquid which is absorbed on the solid, the silica, और भी different types का हो सकता है. So and now as the carrier gas takes with it this volatile component, they are passed to the column. अब column में we have a liquid. Now ये जो molecules है they are either separated, उनका एक main जो process mechanism है that is the boiling point of molecules. अब सब molecules का boiling point तो एक जैसा नहीं हो सकता है. जिनका boiling point बहुत low है they will pass through this column very fast, ठीक? For example, let us say one is low boiling point and then followed by, so one has low boiling point, so one followed by second followed by third, for understanding. तो जिनका boiling point low है they will pass fast through this column. They will pass through this column fast. जिनका boiling point बहुत high है so they will spend some time here. इनका boiling point बहुत ज़्यादा है, उनका थोड़ा सा liquid भी components present होंगे उनके साथ. They will not be fully volatilized. So what they will have some sort of interaction here with this liquid phase inside the column. So low boiling component they will come first, and then they will be detected by a detector. ये detector जो है important, it's an important component in this topic, detector. जो हम इंशाल्लाह next class में will deal with the detectors. That can be any type of detector. Usually जो हम एक important detector हमारे पास जो हम पढ़ते रहते हैं that's mass MS detector, mass spectrometry detector. वहाँ जैसे ही इसमें जो compounds आते हैं फिर यहाँ they are getting ionized by this electron beam, उन पे जो है हम shine कर लेते हैं and then they get ionized. For example, there was a molecule M that gets ionized to M plus, and these ions are then getting detected here. We'll discuss this detector inshallah in our next class. That will be basically on the detectors. So once detected, then again with the help of our computer we can actually getting the graph, and that graph is signal versus the time, retention time, and then we have the similar kind of peaks. So the peak that comes first is low boiling point. It is low boiling point. That's why it comes first. That means the retention time is less. That means it stays for less time in the column. That's the basics of the retention time. और जो दूसरा यहाँ peak है, इसकी volatility उसके बाद थोड़ी सी ज़्यादा है, इसका boiling point थोड़ा सा ज़्यादा है, और इसका boiling बहुत ज़्यादा है. That's why it's coming late from the column. So in this way, we are in a position to separate the various molecules which have the low boiling point with the help of gas chromatography. So in this case, the important point हमारे exam में आ सकता है, that is the gas we use as a mobile phase that is unreactive. It's like the inert gas like helium. It can be hydrogen or this is nitrogen also. It acts as a carrier gas. It basically carries the sample from the volatile point from here into the column. And it actually यहाँ वो phenomenon नहीं important है, ये बहुत important है. जैसे most of the chromatographies या जो हमने अभी तक पढ़ा liquid chromatography, उनमें जो components थे they are basically partitioning themselves between the stationary phase and the mobile phase. और उस partitioning की help से, interaction की help से they are getting separated. यहाँ ऐसा नहीं, it is wholly and solely based on the boiling point. और उसके अलावा भी sometimes अगर boiling point same होगा, ये important है. Let us say इनका boiling point same है. Are there close boiling points? Close. Then at that time the polarity of the molecules matters. दो में से जो ज़्यादा polar है, that will interact with this liquid, and if it is more, let us say इसकी polarity ज़्यादा है, so since it will interact with the liquid, it has some polarity, so it will pass through quickly. since its polarity is less, so हमें जो पहला peak मिलेगा that will be 2 rather than 1. So mostly it is the boiling, the volatility, but in case if the boiling point is closer, that is the polarity that actually helps us in the separation. And the column most commonly we use, that's the liquid material which is absorbed on the solid packed material silica. And this is the basics of the this is the gas chromatography, and it can be gas solid or gas liquid depending on what's packed inside this tubular column, and most commonly it is liquid, that's called gas liquid chromatography. So this is all about the basic setup of the basic principle in the gas chromatography. I hope you understood this. Then we'll tomorrow deal with this detector systems and some more things which are involved. Till then, this is enough for the day. बहुत important topic exam के लिए.